Hello guys, another video from me, Erven Cabral. So IT-1103, IT-2103. Um, for today's video, I would like to talk about the activity for Chapter 5 NetAcad, Cisco Networking CCNA1. So let's start. As you can see on the screen is the activity 1. First activity in Chapter 5. In which MAC and LLC sublayers. In this instruction, description of the MAC and LLC sublayers are provided in the table. Click the MAC or LLC fields in which to match the description to the correct sublayer. MAC means what's that MAC means? LLC means logical list control. Right. So control the network interface card through software devices. Of course, it's logical. Works with the upper layer to add application information for delivery of data higher level protocols, as well as LLC. Works with the hardware to support bandwidth requirements and checks errors in the bits sent by receivers. Yun, I remembered. Media access control. In this section, it's media access control. Control access to media. It's right there. Control access to media through signaling and physically media standards requirements. So in this last two layers, we just need two answers for us to get the correct answer. It's all correct. In this section, it shows you the difference between logical list layer, list control, and media access control. Now let's go to the next one. It's the second activity for Chapter 5, which is the identify the Ethernet frame field names. Okay, number 1 is use pad to increase this frame field to at least 64 bytes. It's the 802.2 header data. Okay, describes by which layer protocol has been used. It's type. The frame originating NIC interface MAC address. The source address. Purchase it. Assist a host of determining if the frame received is addressed to it. Destination address. Address to it. Notifies the destination to get ready for a new frame. It's the preamble. Synchronizes. I will explain to you about all this later on. Synchronizes sending and receiving device frame delivery. Start and frame delimiter. Detects errors in either from frame check sequence. Let's check it. That's all correct. So next one. Ethernet frame fields. You need to classify in which from 7 bytes to 4 bytes. The drag the Ethernet frame field need to correct the location of the diagram. So number 1 from this is the preamble, which is 7 bytes, and the 1 byte is the start. Frame delimiter, destination address, and the source address, and also the length. 8.802.2 header data, as well as the frame check sequence, which is the 4 bytes. So what's the basis on this? It's from 7 bytes to 4 bytes. It's the bytes inside the process from which the layer, the fields are connected in two. So next one is the switch it. I've done this last required activity, the switch it one with the title. So I will explain it to you again. Instructions: determine how to switch forward a frame based on the source MAC and determine the destination MAC address and information in the switch MAC table. Answer the question below using the provided. So this one is the switch, the Catalyst 2950 series, and this at the bottom are the host, and this is the frame which will be delivered, which will forward it. So this is the frame, which is consists of preamble, destination MAC, source MAC, length type, encapsulated data, and end of frame. This is a process, and as you can see on the MAC table, wait, the the switch is composed of 1 2 3 4 12 1 to 12 ports, and it's respectively named as FA1 to FA12. So here in MAC table you can see the FA1, the ports named by it. So number one question: where will the switch forward to the frame? As you can see, the destination of the MAC is FF. So destination of this is the FA1, FA3, FA5, FA7, FA1, FA3, FA5, and FA7, as you can see on the source. In the switch, that will be there, will be forwarded. So let's check it. So when the switch forward the frame, which statements are true? Frame, number one, let's read all five. Switch adds the source MAC address to the MAC table. Adds the source to the MAC table. Add here. The frame is broadcast. Frame will be forwarded to all ports. I think this is the one. Let's check it. Oh, it's correct. Frame is a broadcast frame and will be forwarded to all ports. When we see to all ports, in one to all ports, in this one, OB, OA, OB, OC, and OD, the sender itself will not send because obviously it has the file because he's the sender. So that's all for switch it. Let's go on to the last. It's composed of two buffer frames until the full name must be received to the switch. Starting forward. Check the frame for errors using releasing it out its switch ports. The full frame was not received. The switch discard it. Store in frame again. Store forward rather. No errors. Checking frames is performed by the switch before releasing the frame out of its port. It's cut through because no errors is performed. Switch releasing, it's released. A great method to use to conserve bandwidth on your network. It is a store. The destination network interface card or NIC discards any incomplete frames using frame forward destination method. Discard, the word there is discard, so let's check it. It's all correct. It's incorrect because we forgot the last one, which is the also the cut through, which are correct. Now the last activity for chapters 5, the frame forwarding method, in which is we will answer it. So guys, in this last activity for chapter 5 is the wait I should turn off. Okay. Is the cabling used in the topology will be straight through. To find where the PC2 is located, PC1 will be out of broadcast data frame. PC will respond back to the PC1 by sending back a message. By sending back a unicast message. If PC2 receives only half the data in the frame, it will discard it. If PC2 receives many demands frames in port 3S1, likely will change back to store and forward. It will store and forward. Let's check it. Oh, it's correct. Okay guys, that's all for today's video, and I would like to thank you for um, being with me, and that's all. Thank you very much.